Okay, so now we're finishing up the last part of 4.2, and we are working on adding and subtracting rational expressions. So the key thing to remember is that as you need a common denominator for regular fractions, you also need them for rational expressions. So the way I like to think of it is the easiest way to find a common denominator for any fraction is to add them together. So if I have, is to multiply them together. So if I have 2/3 plus 4/5, this is the idea of bow tie method, that the easiest way to find your common denominator is to multiply those together. And then you're multiplying the numerator by whatever it's missing. So 15 is 3 times 5. This is missing the 5. This is missing the 3. So that's essentially what you're doing when you're doing bow tie. You have 10 plus 12, which would give you 27 over 15. With the rational expressions, you're doing exactly the same thing. So for number 1, the easiest way to find my common denominator is to multiply those together. So I have 3x and 2y. So those are going to be my denominators. I'm going to multiply each by the one it's missing. So this numerator, it's kind of that bow tie method thing, is missing 2y. This numerator, 4y squared, is missing the 3x. So that's what we're going to multiply it by. So now you would get negative 14xy squared plus 12xy squared. Because they are both xy squareds, we can combine those together. So negative 4 plus 12 is negative 2xy squared over 2 times 3 is 6, x and y. We can simplify that. You always need to simplify down as far as you can. So negative 2, 6 reduces to negative 1/3. Our x's are going to cancel out, and we have more y's on the top than on the bottom. So our answer would be negative 1y over 3, or just negative y over 3. When you're doing, when you're using rational expressions, and especially when you're using subtraction, I like to change subtractions to addition problems. So just as subtraction is the same thing as adding a negative, I actually change this to adding a negative. I think it's much easier to just have that set up as an addition problem. So for this, my common denominator is going to be these two amounts multiplied together. So I have x minus 3 and x minus 1. And then the first fraction is missing the x minus 1. The second fraction is missing the x minus 3. Now you're just multiplying across 2x minus 2 minus x plus 3, and simplifying. 2x minus x is x. Negative 2 plus 3 is positive 1 over x minus 3 and x minus 1. Remember, you cannot cancel these x's here. These expressions, x plus 1, x minus 3, x minus 1, are all, each individual one is one piece. You cannot section them out. So you can't cancel. We're going to talk about that more in class. Okay? So, going on to number 3. Again, the first thing I would do is change this to adding a negative. Now you have to look and see what you have. I've got 3 and 5, so that gives me a 15. I have a B, an A, and a C on each side. Each side already has a C, so I don't need to multiply that, but that is going to be part of our common denominator. So on my left-hand side, it's missing the 5, and it's missing the A. It already has the B and the C, so I need to multiply this by 5A. This side is missing, it has 5AC. I'm missing the 3 and the B. So now I need to multiply those together and put my answers here. So 4 times 5 is 20, A times A is A squared, plus negative 15 times 3 is negative 45, and B times B is B squared. Now, what you always want to do is you want to look at those coefficients and see if there's any factor that can come out of all three of them. So in 20, 45, and 15, I can take out a 5. So we're going to simplify that down to 4a squared minus 9b squared all over 15abc. Some of you may be looking at that and seeing that that is actually factorable, that top one. So this answer here would be fine. You can't really simplify more than that, except if you were to factor the top, which would factor to 2a plus 3b and 2a minus 3b all over 15abc. I would accept either one of those answers as an answer. Okay? Okay, number 4. So we've got x plus 2 as our denominator here. Here we have 3x plus 6, but you can factor that out to 3 times x plus 2. So once I factor things, I tend to cross them out so we don't have any confusion going on. So now my common denominator would be 3x plus 2. 3 times x plus 2. So the only thing, so this side's not missing anything. This side has an x plus 2, but it doesn't have a 3, so you would need to multiply that top by 3. So then you would get 9 plus 4x plus 5, which gives you an answer of 4x plus 14 over 3. We can multiply that out and get 3x plus 6. Again, you cannot simplify, for example, you can't just simplify the 14 and x. The 4x plus 14 is one piece, the 3x plus 6 is one piece. If there was some common factor that came out of all 4 of those numbers, then we could simplify it farther than that, but there isn't, so we can't. Okay? Okay, 5 and 6 is going to require you to factor everything first, and then see if you have common denominators, and if not, to make common denominators, and then multiply. So 3x, start with one at a time, get them all factored first before you try to do anything else with them. So 3x plus 3 factors out to 3 times x plus 1. On the bottom you have x squared plus 2x plus 1. That factors to x plus 1 and x plus 1. Plus x minus 1. And x squared minus 1 is one of our special case polynomials. That factors out to x plus 1 and x minus 1. So our common denominator that we have would be this left denominator times this. However, we already have one of those x plus 1s accounted for. So our common denominator is going to be an x plus 1, another x plus 1, and an x minus 1. We could add that x plus 1 in there, another one. We could have all 4 of these. But this one is already showing up in both, so we don't need to multiply it by it again. We could. It would end up factoring itself out later on in the process. So this side is now missing x minus 1, and this side is missing one of our x plus 1s. Now you're just going to multiply all of this together. So we would get here, x plus 1 and x minus 1 is x squared minus 1. That's one of our special case polynomials. We also have that over here. So if I just bring that down, I would have 3x squared minus 3 plus x squared minus 1. Now I can combine, I would have 4x squared, negative 3 minus 1 is negative 4, and I would have x plus 1, and x minus 1 on the bottom. Now you have to ask yourself, if you leave it like this, it's not technically factored out all the way, so you would need to keep going on that. So because I can take a 4 out of both, I would get x squared minus 1. I do know that this x plus 1 and this x minus 1 on the bottom would also give me x squared minus 1. So you can go ahead and multiply those two back together. Then these two are going to cancel. So your final answer is just going to be 4 over x plus 1. Okay? Last one is the same idea. Factor them first. Figure out what factors you're missing. Multiply the opposite by that. Again, because it's subtraction, I change it to adding a negative. So let's factor the bottom. This is a special case trinomial. So this 4x squared is a perfect square. 1 is a perfect square. So you get 2x. Our signs are negative, minus 1, and 2x minus 1. 20x squared minus 5. You can factor out a 5 and a 4x squared minus 1. Which would further factor down, this is a perfect square, this is a perfect square, no middle term, and there's a negative, so that's going to be 2x plus 1 and 2x minus 1. So as you go, I cross things out. So now we've got, if I was to make sure that everything appears once, so I have a 2x minus 1, I have another 2x minus 1, I have a 2x minus 1 already over here. So this is kind of accounted for. It appears in both. But I need to have a 5. I'll put that out in front. And a 2x plus 1. So I should have 2x minus 1s. I've already got one here, so that one's okay. And then the 5 and the 2x plus 1. Once you have them broken down into factors, it's much easier to see what you're missing so you know what you need to multiply by. So on this side, I have my two sets of 2x minus 1, but I'm missing the 5 and the 2x plus 1.
Call from.
So sometimes on these, until you get used to doing them, it might be easy to highlight. So on this side, you've got a 2x and a 1. You've got this one and this one. So you're missing the other two. You're missing the 2x plus 1, and you're missing the 5. Okay. On this side, you could use a different color highlighter, that's fine. On the right-hand side, you have a 5, a 2x plus 1, and a 2x minus 1. So what it's really missing is the other 2x minus 1. Okay. Now it's just a case of multiplying out. So if you were to multiply this first, you would have 8x plus 4, and then we would need to multiply that by 5. So you would get 40x plus 20. On this side, you need to multiply those together. You get negative 10x squared plus 5x. Now we've got to combine things together. So we would have negative 10x squared plus 45x plus 20. We probably need to see if that's factorable. I know I can at least factor a 5 out of it. So on the bottom, I still have 5, 2x minus 1, 2x minus 1, and 2x plus 1. Okay? I'm going to continue this on the other side. So negative 10x squared plus 45x plus 20 over 5, 2x minus 1, 2x minus 1, and 2x plus 1. Make sure I've got that right. Okay, looks good. So this bottom part we're just going to ignore for a minute. The denominator's not helping us right now. So I'm going to try and simplify this out. I know I can definitely take a 5 out of everything. So those are all multiples of 5. So I get 5 times, and I'm actually going to take out a negative 5. I usually like to make sure that that coefficient, that leading coefficient is positive. So I'm going to take out a negative 5. So I would get 2x squared minus 9x minus 4. Okay, so I'm just going to work with this part for a minute, this 2x squared minus 9x minus 4. Let's double check that. Negative 5 times 2 is negative 10. Negative 9 times, that should be, times negative 5 is 45, that's correct. And negative 5 times 4 is positive 20. So far I'm okay. I'm going to see if this is factorable. I don't know if it is or not, so we'll just see if it is. So if I use BFDs, I get x squared minus 9x minus 8. And I don't think that's going to be factorable because this would have to be a positive and a negative, and there's no factors of 8 that have a difference of 9, so that's not going to be factorable. So I've got negative 5 times 2x squared minus 9x minus 4 over 5 times 2x minus 1, 2x minus 1, and 2x plus 1. So the only thing really I can factor here is my 5s. So that's going to be 5 and a negative 1. So if I were to multiply all that out, I would get negative 2x squared plus 9x plus 4 all over 2x minus 1, 2x minus 1, and 2x plus 1. And that'd be your answer. And I tend to like things to be left in factored form. We can't factor this one. Even if I were to multiply that, that's negative 8. Your only options are 1 and 8 and 2 and 4, and none of those have a difference of 9 in between. So this would be your final answer for number 6. Okay? Plan on doing a lot of practice on this. I gave you the skills sheet, so this would be section for module 4.2. The skill sheets that I gave you would be skills practice, 8-1 and 8-2. Okay? Remember that the keys for those are on School Loop, and you should be working on these as we go on. Please do not leave those till the last minute, because this is a section that just requires practice, and it requires you to know your factoring really, really well. So, that's it. See you after Thanksgiving break.